There's my topic, Tropical Data Hub. That's a pretty dry topic, and you've heard my CV. It's a little bit sciencey and it's a little bit dry too, but I hope that by the end of this 15 minutes that there's an idea here that at least you understand and you think might be important too, because it's actually a very simple idea, but I need to take you on a journey that led me to start thinking about things this way. And before I do that, we need to start thinking about two things. We need to think about where we are and all our digital stuff. So right now we're in Singapore. We're about 130 kilometres away from the equator of the Earth. Arguably the richest city in the world. About 1 in 6 people here is in a millionaire household. And the digital world has completely overtaken the universe that we're sitting in. You know, a few years ago no one had a smartphone. Now there's nearly 2 billion smartphones on the planet. They're certainly will be by the end of 2015. Everyone's lives are being consumed in digital media day to day through social media and other forms, and it's the same thing that's happening in the worlds of research and science. We are generating more and more data. So our digital stuff somehow needs to be managed and understood. But I want to dwell for just a moment on the tropics, because it's where we are. It's the topic of today's discussions, and although a lot of people talk about the tropics, not a lot of people think about it and understand why it's so important. It's about half the world's landmass. Now, this standard Mercator map projection that we're used to using in atlases and schools is actually very unrepresentative of the planet. In fact, it's argued that it's been one of the reasons why the Cold War emerged, because this huge landmass of Russia hooked over the US. But in fact, the tropical region between the Tropic of Capricorn and Cancer is actually half the world's landmass. And we don't often think about that. It's 2/3 of the world's population, and not only that, it's the world's poorest billion people live in the tropics, and the world's next 2 billion quite poor people live in the tropics as well. But on top of that, it's an area where there's vast amounts of wealth in other regions and growing wealth. So at the moment it's only 20% of the world's GDP, but by 2050 it'll be more than half. So there's going to be enormous growth and change and challenge in this region, socially and economically and politically. But you've got to weigh that on top of the fact that it's actually a fragile ecosystem as well. So the greatest chunk of the world's biodiversity and the greatest number of species of plants and animals also live in the tropics. So there are going to be huge opportunities and problems, particularly over the next 50, 80 years as climate change unwinds inevitably. And so it's going to have big impacts through the tropical region as patterns of precipitation, of rainfall change, as maybe people have to move, extreme weather events. All those things are going to start unwinding through the tropical world in the next period of time. And if we're going to actually thrive and prosper, we're going to have to understand these things in different ways that we've been doing. And to sort of bring this home, this is a slide from Professor Tim Jackson from University of Surrey, from a TED talk he gave a few years ago, which absolutely influenced me. What he's done is he's worked out that today, or actually in 2007, the carbon intensity, that is the number of grams of carbon dioxide produced per dollar of GDP, is in 2007, 5 or 6 years ago, is 768 grams, so about 3/4 of a kilogram of carbon dioxide produced for every dollar of gross domestic product on the planet. Now, don't worry about these scenarios, but let's look at here. If we can assume by 2050 that the world's population grows from 7 to 9 billion, which let's hope it's only 9 billion, but if we're to resolve these issues of inequality of wealth and people are actually moved up to a higher standard of living, if we could get to a point where in 2050 incomes are equitable at about the 2007 European Union level plus 2% growth per annum, so that's a world which is equitably distributed and everyone's living a reasonable standard of living, we'd have to get that number down to just 6 grams of carbon dioxide per dollar of GDP. We'd have to have 130-time improvement in our technology and our ability to produce goods and services while absolutely catastrophically reducing the amount of carbon dioxide we emit into the atmosphere if we're to avoid the most extreme and serious climate change as predicted by the International Planet for Climate Change. And if you think about things like that, the challenge before us is absolutely astronomical. So we're not going to get there by business as usual. Business as usual has got us to this point. We need to go somewhere far beyond. And so sometimes I like to think about tropical science, knowledge and innovation. We've got to think about the tropics. The tropics is a big part of this solution to this problem because it's where the people are, it's where the growth's going to be happening. So we're going to be part of the problem and we will be part of the solution. So we have to understand new ways to do things. We've got to innovate in a completely different set of circumstances, which is actually exciting, but it's also going to be challenging. And we need to, and I spent a lot of time thinking about what exactly you could do to do that, because these problems are actually quite large. So sometimes I feel in my job I'm like this man, I'm just covered in mountains of technology. There's digital detritus, you can't lift your head for being surrounded. But you know, I think like that, and then I think back to just a bit over 40 years ago. This is a picture of the computer called the AGC that took man to the moon. So that's the computer that was on the lunar module that Neil Armstrong and Buzz Aldrin took to the moon. It navigated them down in the lunar lander, it took them to the moon and back. Now, if I compare that to the smartphone in your pocket, and everyone have a smartphone, today's smartphone is about 400 or 500 times smaller. It's about $55,000 times less expensive. It's about 2,000 to 3,000 times faster. It's got 16 million times the memory, and it uses about 1,000th of the power of this thing that took people to the moon. And yet we're busy trailing SMSs and maybe cruising the odd website. So we have in our technology, in our hands, extraordinary power. And we're creating masses of data beyond imagination. But how are we using it, how are we sharing it, and how are we progressing with that? And the problem in data actually even gets more interesting because this graph here shows in the red roughly what we'd call the developed world and the population in the developed world, and the blue is the developing world. So arguably, most of our science and technology has been generated by people living in this red zone. There's a few odd exceptions, but that's generally probably true. But as the rest of the world develops, a lot of it in the tropics, this extra growth in the number of people producing and researching and hopefully innovating is going to be enormous. So we're going to get this massive multiplication of talent on the planet and this massive multiplication of data and information that we have to share and somehow navigate through. So this is actually quite exciting, and I don't think people have quite realised that as an expert, anyone who's an expert today has their body of knowledge and their college that they talk to, and anyone who's an expert really struggles to keep on top of that body of knowledge. But imagine that multiplying by 10, by just that factor there. And then we're going to have more and more digital knowledge created. So how on earth are we going to innovate and research and exploit this information when individually we're going to become more and more insulated and actually more and more ignorant because there's so much happening that we can't get our head around. So we're actually going to be drowning in data. There's a data deluge on, there's a technology deluge, and we have to find a way through it if we're going to navigate our way out of these big problems. So one of the things I always think about is open data. At the moment, huge amounts of valuable information are tied up by corporations and companies behind paywalls. It's just not shared openly. We can't access the information that's most critically important. It's patented. And in other ways, it's just remote to us. So movements like Creative Commons and the open source movement are really challenging these models of paid data, these models of closed source enterprises. By opening up things, everyone wins, everyone gets better. And you know, if you think about this, you know this from these aphorisms, and these are things from Francis Bacon and Socrates and Aristotle even, you know, knowledge is power, the pen's mightier than the sword. The only good is knowledge and the only evil is ignorance. But we are living in an information age, and yet we are not actually exploiting that information age. So we need ways to cut through to find the things that are important to us. Now, there's a lot of information science that's been brought to bear there, and a lot of corporations are trying to make money out of it. But in some ways, those things are too slow, and in some ways, they're possibly too complicated. So my simple idea is this, that I've called it the Tropical Data Hub, and what we want to do is try and create a hub, a repository for important, open, tropical information. We don't want to make it just a specialist hub for scientists or researchers or medical science. We want to make it totally open. We want to make a repository for business information, for social information, for cultural information. And we want to focus it on this tropical region because this is where the action is going to be happening. So we want to make this an environment where people can go to, the citizens of the world can go and contribute and find knowledge that's open, that's clearly available, and hopefully we can take different pieces from different sources and aggregate it and synthesize it to create new things. So I'm going to show you a couple of examples where my group at James Cook have been putting this together and trying to do good work with it. So this is my favourite bird. It's the Eclectus parrot. Now, fortunately, in Singapore, this isn't an endangered species. In fact, it's not of concern through Southeast Asia. But in Australia, the Australian Eclectus parrot is actually extremely vulnerable. It only has a very small ecological niche in Australia, and the particular Australian subspecies is under threat. So one of the tools that my group's produced is called Edgar. Now, the way it works is you can see this green and yellow here. This maps the areas of climate in Australia where that bird can live. So outside that zone, it's either too hot in particular or too dry for that bird to live. It's only in these very special tropical regions where there are quite high mountains where the animal can actually survive. And what we've recorded here are all the known observations, and bird watchers are great. You know, they're quite intense about their birds, so they'll contribute their data for free. And so we've got verified records and unverified records, and people can log in and contribute records of sightings of the birds, and we can build up patterns of their behaviour and patterns of movement. So that's very nice. We can see where they are, where they ought to be. That's great, but what's going to happen into the future? And this is where a range of modellings happen. So this website makes a lot of really complex information easy to access, and it's brought together whole ranges of data. So what we've done is we've got future climate projections. We've taken the International Panel for Climate Change's most extreme scenario for climate change, that is, we don't do anything about greenhouse gas emissions, and we calculate what the future climate will look like and overlap that on the species, and then we play the movie. And if we play the movie out to 2050 or 2080, you can see all the green's gone and all my favourite birds gone. It's progressively moved up the rainforest slopes to cooler and cooler climates till it can't live anymore, and it's gone. And we've got that for every bird in Australia. And we want to have that for every bird in the tropics. And it really brings it home to people when you can't necessarily see changes day to day. You know, if I ask people about the climate, they'll say, give me a record, which is probably about the last 3 or 4 years of thinking, but it's very hard to project forward. But things like this make it real. And then we've actually run the scenario with the most favourable scenario. And in the most favourable scenario, we do something about climate change and we reduce greenhouse gas emissions. There's still plenty of green left on the map, and my grandchildren could enjoy that bird in that part of the world. But our choices are stark. So we've produced a number of tools inside this tropical data hub environment that take data from many different sources, from many different owners, and they synthesise them together in ways that they weren't originally intended to do it. But by taking this data, you can produce new and different ways of thinking about it. And I guess another example I have is this thing called the Wallace Initiative from Jeff Price at the World Wildlife Fund. This is mapping 50,000 species of plants and animals, and it's using the same basic algorithms underneath it. This animal here, particularly attractive thing, the Bufo marinus, or Australian cane toad, actually came from South America. Some Australian farmers thought that it would help their cane production in North Australia because it would get rid of a cane beetle, but they didn't know that the thing couldn't jump to the top of a cane stalk. So all it did was multiplied, and it's gone throughout North Australia, and you can see this green part of its current distribution. But here's a good example of climate change. If we take by 2080, and we look at it under a severe climate change condition, you can see this purple region will be the only part of Australia that will support the cane toad. So it might collapse under climate change scenarios. That's not a bad thing. So we want to create more tools like this to bring information to the public, but we don't want to just rely on science, we want cultural data in here. There's many things that we can synthesize together if we start to share and open up our data forms. And so ultimately I'd like the idea, the concept of the tropical data hub to be something that isn't dry and that lots of people know about. And I was actually really thrilled driving to the airport to fly here, because I thought someone else has got the idea too. Someone else has got their tropical data hub, their TEDx number plate on their car, sitting in Townsville. So someone else has got the idea. When we've got millions of those and we're sharing, then I'll know we've achieved something. Thank you very much.
Wow, so much we can do with data. Imagine sharing all